In this lesson, we're going to expand on what we covered in the last lesson to solve what are called multi-step equations. These are equations that require more than one step to solve them, but all of the steps are going to include concepts and skills that we've covered so far in this video series. So the outline for the process is this. Simplify each side of the equation, and you do that as much as you can. And I want to call your attention to not that, okay? Each side of the equation, and when we talk about the sides of the equation, we mean the sides of the equal sign. So you'll look at the left side of the equal sign and simplify just that side. You'll look at the right side of the equal sign and simplify just that. Now, what do we mean when we say simplify? We want to be really explicit with this. What we mean is distribute. If there is distribution that can be done, then we want to carry out that distribution. We also mean something called combining like terms. Terms are things that are added and subtracted, and like terms have the same variable part. And we can only combine things that have the same variables because the variable represents an unknown number. That's like being multiplied in, maybe it's standing alone, but you cannot combine something that has this like unknown in it with something that doesn't have an unknown in it because we don't know what that unknown is. And then the second step there is use inverse operations to isolate the variable. So inverse operations are these: adding and subtracting. So if you see adding in the problem, you'll do subtracting in the solution. If you subtracting in the problem, you'll do adding in the solution, and your multiplication and division. Same there. If you see multiplication, then you're going to carry out division. If you see division, then you'll carry out multiplication. And this last piece, isolate the variable, that means get the variable alone. So we might start out with some kind of like big equation, and they will get more complicated. So we'll start with like some simple ones, and in a couple of sections we'll add on like more details. And our final line should be something like this: x equals some kind of number, or some kind of number equals x. So this is the goal. This is what we're aiming for. Remember, what we're looking for is the value of that variable that is going to make the equation true. And that goes back to the definition of a solution. So I'm going to do a couple of examples, and we'll look at what these different things mean, and that'll be the bulk of the lesson. And then for the practice, I might not go through the explanation of all of the problems because I think we're at the point where the explanation will end up making the video too long. But we'll see. So let's take a look at this. Here's the x, okay? This is what we're looking for. By the time we're done with the problem, we want x equals down here by itself. The x is being multiplied by 1/3, and then we're adding a 6 to it. So if you think about your order of operations, let's just say x was 6. Okay, now you're like, whoops. You're saying, where did you get a 6 from? I made it up. Okay, so let's just say x is a 6. If you were to do this out, you would multiply first, which would give you 6/3. Then you would do that division to get 2, and then the last thing you would do would be the addition. Clearly, x does not equal 6 because that did not work. But the point that I'm trying to show here is what you did first was the multiplication. And then after you do the multiplication, then you do the adding. When you go to solve an equation, you actually reverse the order of operations so that the last thing that you did is the first thing that you're undoing or you're going to get rid of. So in this problem, we multiply by 1/3, then we add 6. So when I go to solve it, the first thing I'm going to do is undo the adding by subtracting 6. I'm going to bring down that 1/3 x. Now remember why these cancel out. 6 minus 6 is 0. Okay, we don't usually write that plus 0 because we don't need to, but that's why they cancel out. And then you might want to kick in your adding sign numbers here. So this would be -8 plus -6. So we go 8 to the left and then 6 more to the left, which is going to give us -14. Now this brings us back to what we were doing in the last lesson, where we can solve this by multiplying by the reciprocal. So I'm going to go ahead and multiply by 3 over 1. You could also divide by 3, or 1/3. Over on the left, 3 times 1 is 3, 1 times 3 is 3, and 3 over 3 is 1. On the right-hand side, this is what is that? -42 over 1. But remember, this is like an extra step here. 3 over 3 is just 1. So it's 1x, and then -42 over 1 is just -42. So if you need to, pause the video there and just kind of go back and look at that. Make sure that you understand what's happening in each step. Now let's take a look at what combining like terms is. What do we mean when we're saying combining like terms? So suppose I have 7x minus 3x minus 8 equals 24. On the right-hand side, there's nothing to simplify. It's just a 24. On the left-hand side, though, there is some stuff that we can simplify. And notice that I have these two terms that both have an x in them. Okay, these are what are called like terms, which means that we can combine them. So the easiest way to think about this is I tell my students, think of your favorite noun, whatever your favorite noun is. I always go with kittens, okay, because who doesn't like kittens, right? So if you have 7 kittens minus 3 kittens, what do you have? And usually with the use of that noun in there, most students will say, oh, you have 4 kittens because you had 7 and then you gave away 3 of them. And so you are left with 4. And so the 7x minus 3x simplifies to 4x. And then good structure to your problem says that you bring everything else down. So you bring down the -8, bring down the equal sign, bring down the 24. Nothing else should go missing. We should not see fragments of work in there. Now we want to isolate the variable. So what's happening to the variable? Well, we are multiplying by 4, and then we are subtracting 8. How do I undo subtraction? I undo it with addition. And so I'm going to add 8 to the left side. If I add 8 to the left side, I also need to add 8 to the right side. Now notice I switched up the notation. So instead of doing it vertically, I'm doing it horizontally. That's just to keep things fresh. -8 plus 8 is 0, which is why that drops out. 24 plus 8 is 32. This we established was multiplication, and so we can undo multiplication with division. 4 over 4 is 1, which is why that cancels out. And 32 divided by 4 is 8. Now you can check answers, because remember several lessons ago we talked about what is the solution to an equation. Well, the solution is the value that makes the equation true. So let's say it is a high stakes kind of situation. It's the unit test, your final exam, a state test, something like that. And you've got the time, you want to make sure that you're solving the equation the right way. Well, what you can do is plug it back in. And this strategy actually works great for multiple choice tests. So we think that 8 is the solution. So what we do is we go substitute in the 8. 7 times 8 is 56. 3 times 8 is 24. 56 minus 24 is 32. And 32 minus 8 is 24. And notice that it does make the equation true. So you can always go back and check your work, or if it's a multiple choice test, you can actually plug in the answer choices until you find the one that works. It's a little bit long, but it does work. And in a high stakes environment where there's a lot of pressure to get things right, it's not a bad idea to have that foolproof thing in your back pocket. For this next one, we're going to look at two different ways to structure your work. Okay, so on this one, that is the equals sign. That, I'm just making things worse here, equals 28. All right, so on this one, remember our steps from way back here, that you do want to distribute early on. So we'll distribute and then we'll combine the like terms. This is the first one that we've seen that has distribution. So I do have some distribution right here where I have a 3 and I'm going to distribute that 3 through the parentheses. A lot of students like to write the little arrows in. Just remember that the arrows are not the actual process. The arrows are just a way of helping your eyes track. Bring down the 5x. Don't leave the 5x stranded up there. It's part of the problem. 3 times x is 3x. 3 times 4 is 12. Now we have some like terms. I have 5 kittens plus 3 kittens, which of course gives me 8 kittens. We've got way too many kittens. Now we look at what we've got. That was the simplification. That right there is the simplification. The right-hand side did not need simplification. If it did, we would do the simplification on the right as well. But that's what we mean by the simplification, is we go from this statement here to something like 8x plus 12. Now we look at what's being done. So we've got multiplication and we have adding. Multiplication comes first when you're doing it. So when you're solving it, then you're going to do the multiplication last. So here we go. We'll subtract 12 from both sides. This gives us 8x. 12 minus 12 is 0. And 28 minus 12 is 16. This is multiplication, so we'll undo that multiplication with division. 8 divided by 8 is 1. And 16 divided by 8 is 2, and we get an answer of 2. Now, this is what's called like showing the, like all of the steps. Like we're doing the little arrows and we're showing the minus 12, and we're showing the divided by 8. You can do that. There's nothing wrong. There's nothing algebraically wrong with doing that. You just do want to be aware that you don't have to do it all. So on the right-hand side, I'm going to show you what it looks like for process only. So it's the same problem, but this is how I would do the workout. This is how most of your math teachers would do the workout. So we would start the problem the same way, like so, and then we would combine the like terms the same way. So far, nothing different. But an experienced math person isn't going to write minus 12 minus 12. They just look at this. They know that minus 12 is what they're going to do, and they'll jump straight to the 8x equals 16. And an experienced math person does not write divided by 8 and divided by 8 because you know that that's what's happening. So you just kind of go and do the divided by 8 and you jump right down to the x equals 2. And it is assumed that, somebody who's experienced at math could look at this, from here to here, and they could tell you, oh, well, we subtracted 12 from both sides. This is what is normally accepted in your higher level math classes. This is what students do when they're first learning how to do it. And my word to my students is you do this as long as you need to do it until you are comfortable. Don't rush to leaving like pieces of that out if it's going to cause you to make mistakes. Okay. Next one we'll do one more. We'll do one more of these. Okay, so this one has one of those common little mistakes in it. Okay. So this one, the left-hand side does not need to be simplified, but the right-hand side does. A lot of people actually go ahead and switch the two sides around because they like having the variable on the left. Now, this is where that remember what subtraction is comes in really, really useful. We've gone through this, like subtraction means adding the opposite. Right here, it's very tempting to think of this as a positive 5, but it's not. It's actually a negative 5 because subtracting means to add the opposite. So when you go to do the distribution, you have to distribute a negative 5. Not a positive 5. It has to be a negative 5. So let's go ahead and do that. Bring down whatever you're not working with. So if I'm not working with that negative 28, I'm going to bring it down. I'm not going to forget about it. 2 times x is 2x. 2 times 3 is 6. Now we've got negative 5 times x is negative 5x. And negative 5 times 1 is negative 5. In either of these places where I have written plus a negative, you could write a minus sign. So I'm just going to go ahead and rewrite that. I personally, for my students, do not care. Which way they do that. For some students, it's actually easier to do like the 2 plus negative 5 than to do 2 minus 5, but it genuinely doesn't matter. Now, this is another step that we often don't write out, but I recently had a student ask me about this. And it's like the switching of the order. And I had a student ask me, why can you pull like the 2x and the negative 5x and combine those when they're not next to each other and you're supposed to go from left to right? And the reason we can do that is the commutative property of addition that says that you can switch the order. So what we can do is we can switch the order of the negative 5x and the 6, and what that does is it groups the like terms together. And you can do that even from like the far end. You can kind of keep switching the order to put things next to each other. Normally we don't do that though, like we just go ahead and combine them from wherever they are, but I think it's worth seeing at least once why we're allowed to do that. Keep on with that negative 28. 2x minus 5x, well that's 2 plus negative 5, so right 2 back 5 is going to bring you to negative 3x, and then 6 minus 5 is 1. Now we have multiplication followed by addition, so I'm going to undo that with subtraction. So I have negative 29. Remember to think of that as, I copied this problem wrong. Oh, crud. It's going to come out with a lousy answer. It's negative 28 plus negative 1 is negative 29. Over on the right, 1 minus 1 is 0. And we'll go ahead and divide by negative 3. A negative divided by a negative does give you a positive. And that came out terrible because I copied the problem wrong. But it is what it is. That is the correct answer for the problem that I wrote. I hope it's the correct answer for the problem that I wrote. Go ahead and pause the video if you need to go back and just study those steps. Make sure that every single step that I wrote there is one that you do understand, like what's happening, and you're not just copying problems down, that you're not following what the steps are. So please give yourself the time to be able to do that. One last problem. We'll do 66 is equal to negative 6 over 5 times x plus 3. So in this case, you could distribute. The problem with that is that you've got this pesky little fraction out here, and we don't, I mean, I'd rather not like multiply by fractions if I don't have to. Well, we know that if we multiply by the reciprocal, we can get that fraction to drop out. So I'm going to, actually, I'm just going to move it over a little bit, like so. And I'm going to go ahead and multiply by the reciprocal, which would be 5 over negative 6. And I have to make sure I do the same thing on the other side. Okay, and right here, this will be negative 30 over negative 30, and anything divided by itself is 1. All right, on the left-hand side, this would be negative, I'm going to do the division first. So 66 divided by negative 6 is negative 11, and negative 11 times 5 is negative 55. Now, on the right-hand side, well, 1 times anything is the anything, so we don't really need to write the 1 there, and then there's no point in having those parentheses there, like that's just why you, yeah. And then we have a one-step equation. So negative 58 is equal to x. So that is an option if you don't want to distribute with a fraction. So this lesson has already gone quite a bit longer. So what I'm going to do is put some problems up on the next slide for you to practice on, and then I will just show the solutions without actually walking through the solutions with you, because I don't want the videos to really get much longer than 25 minutes. Okay, here they are. 3x minus 7 equals 23. 1/4 x plus 2 equals 3. 4x over 3 plus 5 equals negative 3. 4x minus 3x equals 9. Negative 6x plus 4x equals 2. 19 equals 2 times the quantity x plus 1 minus x. 3 times x minus 2 equals 18. 9 halves times x plus 3 equals 27. And as a special challenge one, negative 2 equals 2x over 3 minus x. Pause the video, work these out, practice your good structure to your problems, work top to bottom, don't drop things out, don't lose your equal sign along the way, and then unpause the video and check out the solutions. Okay, I'm pretty sure I hit record in there because I dragged something from the bottom of the screen, so sorry about like a little blip in that. Here are the solutions to the first three. I tried to do this out where I'm showing like what's happening in each step in a different color so that you can see what's going on. Make sure that you pause on this slide and compare not just your answers, because like Photomath and a million other apps can give you the answers, but compare like the steps, the work, the structure of the work. It doesn't have to look identical to mine, but it does need to be there. Right, here are the next three. This right here is an extra step. So if you have like 4x minus 3x, I wrote 1x, but it's not necessary to write the 1x. So that's just like a little aside there. Again, pause on this and check not just your answers, but your work. You can also write down here, you can write x equals 17. I don't I'm not bothered by 17 equals x, but some people are, so you can always switch the order if you want to. All right, for this one, I actually did number 7 two different ways. The first way is the way that I described in the lesson, where I distributed, so we got the 3x and then the 6, and then added 6 to both sides, and then divided both sides by 3 to get x equals 8. But once in a while, a student will see this, and honestly, I would do it this way because I can see that it's going to work, is you can actually start with that division. And so this is 3 times the parentheses, so you can divide both sides by 3. That's going to leave you, remember 3 over 3 is 1. So it's just going to leave you with the 1x minus 2 equals 6, and then add the 2 to both sides. Both of these strategies work. Both of them are algebraically sound. Whichever one makes the most sense to you is the one that you should do. And then for number 8, this is the one where you would multiply by the reciprocal at the beginning. And the way I did this was I did 27 divided by 9 is 3, and then 2 times 3 gave me the 6. So that's using your skills with the fractions there. Again, pause the video and make sure that you have all the pieces. And then for this last one, this is like the starred one. So the way that I did it the first way, just so you get an explanation, is I recognized that I had division here, and I wanted to undo that division. And so I know I can undo division with multiplication. The slick thing here is that you have to multiply everything. You cannot multiply just some of it. So I multiplied the left side by 3 to get the negative 6. I multiplied the right side by 3, but I have to do everything by 3. You can't just multiply part of it by 3 because everything on the left was multiplied by 3. So everything on the right has to be multiplied by 3 as well. Here, if you divide by 3 and then multiply by 3, those 3's cancel out, leaving you with the 2x, and then 3x gets brought down. 2 minus 3 is negative 1, and then we divide both sides by negative 1 to get x is equal to 6. Another way you can do it is recognize that this right here is a 1x. and then find a common denominator. And so instead of 1x, we would use 3 over 3. 2 minus 3 right here is -1. And then you can, so you end up with -1/3 x. And then you can multiply by the reciprocal, and it will also get you to the x is equal to 6. So study those. It's possible that there's other ways to do that as well. I just took the time to do it 2 different ways, but you might have thought of something else. If you got the 6, you're probably on really solid footing. If you got something other than 6, then something went wrong with it. That wraps up this lesson. In the next lesson, we will tackle the variable on both sides of the equal sign.